Hello there students. So this is the last video about this paper labeled 0625, and this is the questions from 31 to 40. Now here a circuit includes a battery, two identical resistors, and 5 ammeter. It is P, Q, R, S, and T. Those ones here, 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 and here. So the question is, which statement about the readings on the ohmmeters is not correct? So P has a greater reading than Q. P has a greater reading than Q, and this is actually the answer here. This is the one which is not correct because of what? As we see here, between this node and this node, the ammeter P and the ammeter Q are included in the same branch. It's the primary branch, which is including, of course, the battery. So the same current will pass through the two ammeters, which means they will give the same readings. So P has a greater reading than R. P and R, this is correct because this is the primary branch and those two are the secondary branches. All the time the secondary branches will just carry a current less than the primary one, which is this one with the battery. And the PE has a greater reading than R, S, and T. All of those will read or will give values less than P and Q. This is for 31. 32. An electrician set up a potential divider circuit in a fridge so that when the fridge door is open and light from the room enters the fridge, a warning light turns on. Which component does the electrician need for the potential divider in addition to a variable resistor? So for this, because we are dealing with light, that means we need a component using light as a trigger, which is, it's gonna be the LDR. This is the LDR. It's a light dependent resistor. It's a component actually that's changing its resistance depending on the intensity of light incident on it. The relay, the thermistor, and the motors are other components for other cases for sure. So the light dependent resistor is what this electrician need for its work here. A sample wiring diagram for an electric cooker is shown. We have this electric cooker and a metal case with 3 wires: the live, the neutral, and the earth. So this connection to casing means the earth wire is connected to the case. Why is this? Why this is there wire connecting the metal case of the cooker to earth? Is it improves the efficiency of the cooker? No. It prevents the metal case from becoming too hot when the cooker is left on. This is not the answer. It reduces the risk of an electric shock if the live wire touches the metal case. This is the answer actually. The earth wire is protecting us from the risk of electric shocks. And the electric cooker will not switch on without it. This is not correct also. So the answer here is C. 3 statements about A and C about AC, sorry, AC and the DC currents are given. A DC current is in one direction only, whilst an AC current repeatedly changes direction. So DC is the abbreviation for direct current, and AC is the abbreviation of amplitude current. And 3, an AC current is in one direction only, whilst a DC current repeatedly changes direction. So which statements are correct? For the first one, the DC current is one direction. This is correct. And the AC is repeatedly changes direction, and this is correct also. So the one is already correct. DC is abbreviation of currents of direct current. This is correct. And AC is the abbreviation of amplitude current. This is not actually correct. The AC stands for the alternative current. It's not the amplitude current, but it's alternative current. That means it changes the direction repeatedly, as it's shown here. So this one we cannot take it as a true statement. For 3, an AC current is in one direction only, whilst the DC current repeatedly changes the direction. This is not correct also, because this is the exact opposite of the first one. So the only one statement correct here is the one. That means, which makes B is the correct answer for the question 34. Now let's move to the 35. Here, 2 magnets are placed near a current carrying coil. The diagram shows these experimental arrangements and the current direction in the coil. So the current is passing through this coil in this direction. Which statement is correct? Both X and Y are attracted to the coil. Both X and Y are repelled by the coil. X is attracted to the coil and Y is repelled. X is repelled and the Y is attracted. So let's talk a little bit about here. This coil is carrying a current, and there is a soft iron inside of it, which means it's going to act like a magnet. It's actually what we call an electromagnet. And since the direction of this current is like this, we can just use the right hand rule to know what is the direction of the magnetic field created by this coil. As we just put our fingers in the direction of this direction, the 4 fingers and the thumb will automatically show that the direction of the field, magnetic field, is in this to the right hand side, which means for us this side is representing the south. This is the south pole of the electromagnet, and this side is the north one. So the X magnet is representing the south pole to the south pole, which means there would be repulsion. The Y magnet is presenting the north pole to the north pole of the electromagnet. That means there would be repulsion also, which means this electromagnet will repel the X and the Y, both of them. Means the B is the answer for us here. The question 36, which arrangements can be used to step up? It's a step up voltage, here. For a transfer, it's not functioning with the DC already, so this could not be used. It's not working with the DC, with the direct currents. We cannot use, we cannot make a step up voltage, because there must be a change in the field inside the secondary part of this transfer, so they will just generate another potential difference here. So for DC, it's not going to work. For a step-up voltage, the rates between the number of coils or of turns here must be like the secondary turns must be greater than the primary turns, which means the A is the correct answer here. This is actually a step down voltage, a step down transfer. That means it's making a step down a voltage. So the voltage, just like we can get at the exit here, the U2 would be greater than the U1 delivered by a certain AC input. The question 37. Which diagram shows the structure of an atom containing a nucleus and two orbiting electrons? So when we've talked about the atom or the atomic structure, we know that it's composed of what we call a nucleus in the center, and there is electronic cloud. So electrons are charged negatively. Q of the electrons, it is negative, but the nucleus is containing protons and neutrons. The protons are positively charged, and the charge of neutrons for sure equals to 0. They are not charged. So here we have a positive charge at the nucleus, that's correct, but the electrons are not positive. So this is not an answer. Here it's the opposite actually. Electrons are not positively charged and the nucleus is not negatively charged. So this is not again the answer. Here the nucleus is not negatively charged, so it couldn't be the answer. The correct answer for us is C. Two positive charges in the nucleus compound by the two negatively charged charges of the electrons outside of the nucleus here. A nuclide has the symbol C146. Which statement about all atoms of this nuclide is correct? There are 6 protons in the nucleus. So the C, or in general a certain elements in the periodic table, it's represented as X and A and Z. So this is the number of mass and this is the atomic number. Atomic number means number of protons inside the nucleus again. So for A here there are 6 protons in the nucleus. This is actually correct. There are 14 neutrons in the nucleus. This 14 actually is the sum of the Z plus N, means number of protons plus number of neutrons. This is the total number of particles inside the nucleus. It's not neutrons only, but the two. For C here, there are 6 electrons in the nucleus. There are actually 6 electrons, but they are not in the nucleus. They are outside. They are forming what we call the electronic cloud. For D, there are 20 nucleons in the nucleus. No, we have just 14. The table compares the penetrating ability and ionizing effect of alpha particles and of gamma radiation. Which row is correct? Least penetrating, most ionizing. For our case here, the A is the answer, because the alpha particles, they are just need a simple paper to be stopped, and because they have a great mass, so that makes them to be able to ionize other elements when they are just colliding with the other particles for sure. About the gamma is just a radiation. It's a radiation, and it has a very big energy to penetrate many matters. That means we need a thick matter to stop this, not like the alpha. And because it's just energy without mass, that means it's not the most ionizing, but the alpha is the most ionizing element for our case here. The last question here is 40. 40 says, when a radioactive isotope is set up close to a count rate of 38,000 counts per second is obtained. The table shows the count rates from the isotope over a 3 year period. So this is the initial instance. After that, we're going to count for each year what is the count rate there. The question here is, what is the half-life of the isotope? Less than 1 year, between 1 and 2 years, between 2 and 3 years, or more than 3 years. When we talk about the half-life, it's the time when the count, we're going to denote it as A, when the initial counts just like reach its half. That means the initial count here was 38,000, just like counts per second. So we're going to divide this by 2. This is giving like 38 divided by 2. This is almost 20. This is 19, let's say 19,000 counts per second, and the 19,000 is actually between 17 and 26. That means the half-life must be here between 1 and 2. The answer then would be between 1 and 2 years. It's more than 1 year, but less than 2 years. This is the half-life of this isotope. And just like that, we just made it to the end of this paper, and I'm going to see you in the next paper for sure to complete the program. If you do have any questions, just don't hesitate to post them in the comments, and don't forget to like and subscribe in the channel. See you in the next video.